Hi everyone, in this video we're going to tackle some key geometry questions from Leaving Cert higher level papers. We'll work through a mix of angle facts, some similar triangles, congruency and circle theorems, and all the stuff that shows up again and again. Let's break down this powerful geometry diagram that some of you may have seen in your mocks this year and see how many theorems, angle facts and congruency rules that we can uncover in just one question. So we're given a circle with the points A, B, P, Q and R on the circumference. There's also a triangle PQR inside the circle and the line segments connecting various points. We're also told that the angle ABR is 46 degrees and that O is the centre of the circle. So already there's a lot going on in this question and in this diagram. So let's go step by step and see just how much geometry we can use and extract from this one diagram. One of the key circle theorems is the angle at the centre is twice the angle at the circumference on the same arc. So here angle ABR is 46 degrees and it's at the circumference. So that means that angle AOR in here has to be double the angle ABR. So that tells us then that AOR is 92 degrees. So we've already established that angle AOR is 92 degrees, and we can see from our diagram that OA and OR are both a radius. So if I draw a chord connecting AOR, then what we've actually created here is an isosceles triangle. So we have two sides that are equal in length because they are both a radius. So if I have an isosceles triangle, that means that my two angles down here will also be equal. So I can use the facts of a triangle adding up to 180 degrees to help me work out that the angle OAR and also the angle ORA are both 44 degrees. To get that, it's simply 180 minus 92 and then divided by 2, which is 44 degrees. In the question, we were told that this angle here, POA, is also 44 degrees. And we just used some of our geometry knowledge to work out that this angle here is 44 degrees. So if we were to draw the letter Z between these two, we can see that what they're creating are alternate angles. So when we have alternate angles, that tells us that the line PQ is parallel to the line AR. Now, we worked out earlier on as well that this angle in here was 92 degrees because it has to be double the angle ABR. So we can very easily figure out this angle by doing 180 minus 44 minus 92, and you'll find that it's also 44 degrees. So if we're to look at the two triangles, POA and QOR, we can actually say that these two triangles are congruent under side, angle, side, because the sides are a radius. Side, the same angle, and the side. So we can say that those triangles are congruent under SAS. Now, while we're on the conversation of the alternate angles, which we used here to prove that congruency, it's also worth mentioning the other types of angles that we need to be aware of that come in with parallel lines. So they are our corresponding angles, which create the letter F. So the inside angles here would be equal. And remember, these must be parallel. And the other one then is if we have vertically opposite angles, creating the letter X. They are also equal. So we have our alternate angles, which we use in this question with the letter Z. We have our corresponding angles and we have our vertically opposite angles. Another important thing just to be aware of with these type of questions is that if we have a tangent drawn at a radius, so here the line OR is the radius, and then there's a tangent at the point OR, then automatically those two lines will be perpendicular. So something like perpendicular distance could be very useful, or also that idea of having inverse slopes could be very useful. So as you can see, even a single diagram can be packed with geometry knowledge. So always look for patterns, parallel lines to use your alternate angles, corresponding angles, etc. Equal angles, shared sides and arcs, and then apply your theorem step by step. The more diagrams you tackle, the faster these patterns become second nature to you. So I would definitely advise even looking at these kind of diagrams and trying to extract as much information as you can. Okay, now let's break down this next geometry diagram and see just how much information we can extract using our geometry toolkit. So we have this triangle DEF with the points OR, S and Q placed along the sides. And we're given the line segments ORF, FQ, QS and SOR, and they form a parallelogram. You can see those parallel lines marked in. That is crucial. So ORF is parallel to QS, or S is parallel to QF. And the segments then from D to S are labelled as X, and from S to E is labelled as Y. We're now going to just focus on the fact that ORF, this line here, is parallel to SQ. So that gives us corresponding angles. Okay, so we want to start using some of that information. So if I were to draw a line from D all the way up to F and create this shape, we're creating that letter F that we discussed already. So that tells me that this angle and this angle are equal. Also, if I were to draw a line down along here and up across my parallel lines, then I'm again creating that F shape, and so my angles in here would also be equal. So I have the angle DORS is equal to the angle DFE, and the angle DSOR is equal to the angle DEF. Now there's another angle that is also equal or common to both of those triangles. So the smaller triangle being DORS and the bigger triangle being DFE. And that is this angle in here. This angle is common to both of them. So therefore what we can do is we can say that these are similar triangles. When triangles are similar, their sides are in proportion. So now we can write that DOR over DF is equal to DS over DE, which is equal to X over X plus Y. And that is because these two triangles are similar. And this ratio becomes really useful if we're given one side and asked to find another. And they love this type of kind of follow-on question on the exam papers. And similar triangles are coming up more and more regularly. So now let's use the fact that OR, F, Q, S is a parallelogram. So what can we say? We can say that the opposite sides are equal. So OR-F is equal to SQ and SOR is equal to QF. We can say that opposite angles are equal. So the angle OR and the angle Q would be equal. And also the angles S and F would be equal. And we could also say that the diagonals would bisect each other. So if we imagined a line going through here as diagonals, these would naturally bisect each other. Now we don't need this right now, but it is worth keeping in mind. And this intersection here would be a midpoint. Now, if OR-F is equal to SQ, and OR-S is equal to FQ. So this side is equal to this side in length, and this side is equal to this side in length. And we can see that that diagonal is obviously a common side. Then we can say that those two triangles are congruent by SSS. Meaning side, side, side. And this helps in justifying equal segments or angles inside composite figures and diagrams. And we will look at that congruency and how to show it a little bit more in a minute. So now something that they might ask would be, they could say, well, if X is equal to 3 and Y is equal to 4, what's the ratio of area of the triangles DOR-S? So that is our smaller triangle DOR-S to our larger triangle DFE. So what is the ratio of the area of the smaller triangle to the bigger triangle? And since these triangles are similar, so if you remember, we've already shown that they're similar based on the angles that they share, then the area scales by the square of the side ratio. So if I'm to write down my side ratio, it would be X, so my smaller triangle, over X plus Y. That is the side for the bigger triangle. And that would be squared. That would be the ratio of it. And it's important to remember that that word ratio means you're going to be dealing with fraction, because ratio comes from the word rational, meaning rational numbers. So X for us is going to be 3 over X plus Y is 7. And then that's squared, which is 9 over 49. Now, as a decimal, that is 0.18. So the scale factor of the area of triangle DOR-S to the area of triangle DFE is 0.18. So you've heard me mentioning congruency and congruent triangles throughout this video, but what is congruency? So two shapes, usually triangles, are congruent if they are exactly the same size and shape. So that means that all corresponding sides are equal in length and all corresponding angles are equal in side. Congruent triangles can be rotated, reflected or moved, but they are still considered identical. So it is very worth being aware of these congruent triangles. And sometimes we are asked to prove that triangles are congruent. And there are 4 main tests for proving that two triangles are congruent. So I've created a little summary table for you showing that. So the first test is SSS, side, side, side. So what's needed is 3 equal sides, and you use it when you know all the sides. SAS means that we have 2 sides and the included angle, so the angle between the 2 sides. And you'll use it, as I said, 2 sides and the angle in between. Angle, side angle, so 2 angles and an included side. Use it when you know 2 angles and the side linking them. And another one then is RHS, or right angle, hypotenuse and one other side. So this only works with right angle triangles because the right angle will be the same. So if you have the hypotenuse and one other side, then you can also prove congruency that way. The key geometry takeaways then from this video are to watch out for parallel lines where you can create alternate and corresponding angles to help you with the questions. Angles being equal, so things like similar triangles, the sides in proportion with similar triangles, and also the areas in squared ratios. With parallelograms, opposite sides are equal in measure, and opposite angles are equal in, can be considered equal as well. And then also that idea of congruency and how we can use congruency to help us with questions, but also for those proofs. So thank you for watching, and remember to always mark your diagrams as you saw me doing throughout the video, label known angles and continue to fill those in as you go. And a hot tip for you would be to look for parallel lines first, because if you have those parallel lines, you can start filling in some information. Thank you.